All right, ladies and gentlemen, let's talk today about solving systems of equations by substitutions. This is lesson 6.2. We are still working on the same skills from before. This is going to be our big skill for this unit. We're talking about solving systems of equations exactly and approximately when we're mostly dealing with pairs of linear equations. Our first and only vocab term for today is the idea of substitution. In substitution, we have a method of finding an exact solution to a system of linear equations. So the steps that we're going to take to solve these problems by substitution are written below. Please copy them into your notebook. The first thing is that when necessary, we need to solve at least one equation for one variable. So we need to isolate one variable. Then we substitute the resulting expression from step 1 into the other equation to replace the variable and solve. So we're going to solve, if we'd isolated x, we'd plug it in and then we'd solve for y. And then when we get that value, when we have y equals 7, we go back and substitute it in to the first equation and solve for the other piece. We will write our solution as an ordered pair. Now let's practice with this because it sounds a lot more complicated than it is. We can graph, we can solve by graphing, but what if we wind up with a system that looks something like this when we graph it, where we have not at integer values, that maybe this was 1 and this is 0 here, and it's kind of partway between. We'd have to estimate. And graphing is useful, estimations are useful, but in general we want exact answers, and so substitution will work every single time to give us an exact answer, even if our x or y values are non-integers. We can also use substitution when graphing would be impractical because our slopes or our intercepts are really big or really small, or we have giant or tiny numbers. So let's practice with substitution. When I see this here, my first step tells me to isolate one variable if necessary. Well, in this case here, I see that y is already isolated, so I'm going to put a purple box around it. And I know that y is equal to negative 4x plus 12. So every time I see y, I can substitute in that expression. So when I take my second equation now, I'm going to rewrite it. I have 2x plus, I'm just going to put a parentheses around, so I know that that's what I'm substituting in for y, equals 2. Well, y is equal to negative 4x plus 12. So when I do that, now I'm left with only one unknown in this equation. Because there was no coefficient on my y, there's nothing I have to do. Those parentheses aren't necessary in this case. So I'm going to leave it alone, and I get 2x minus 4x plus 12 equals 2. 2x minus 4x gives me a negative 2x plus 12 equals 2. Subtract 12 from both sides, and I get negative 2x equals a negative 10. When I divide by negative 2, I get x equals 5. I'm halfway done. I have my x value of my ordered pair for the solution. Now I need to go back. I'm going to plug it in to that equation that I started with to find my other piece. Y is equal to negative 4 times my x value. Let's do it in purple to stay consistent. Times my x value of 5 plus 12. Well, negative 4 times 5 is a negative 20. Negative 20 plus 12 is a negative 8. So I have both pieces. The way I would write my final answer when I'm talking about solutions to systems would be my x value is always first and my y value is second. My final answer for this problem would be 5, negative 8. Well, let's try again. With this one here, I see that I don't have a variable isolated yet, but if I look at that first equation, it would be pretty easy to isolate x because there's no coefficient on it. So that's what I'm going to do here. And now when I see the setup of this problem, tomorrow I'm going to learn a better way to solve this type of problem, but for today I'm using the skill of substitution. So to do that, I know that I need to get x all by itself, so I take away 2y from both sides, and I'm left with x equals 6 minus 2y. Put a box around it. Every time I see x in that next equation, I'm going to substitute in my new expression. So I have 3 times, well, x is gone, minus 2y equals negative 2. And I'm going to plug in my new expression for x. X is equal to 6 minus 2y, so I can directly substitute in my expression. Now, because that x had a coefficient on it, I know that I need to distribute to get rid of my parentheses. So I get 3 times 6 is 18, minus 3 times 2y, which is 6y, minus 2y equals a negative 2. I can combine my like terms and I get 18 minus 8y equals a negative 2. Take away 18 from both sides and I get negative 8y is equal to a negative 20. If I divide both sides by negative 8, well, a negative divided by a negative is going to be a positive, and 20 divided by 8 is 2.5. I'm halfway done. Now I need to take that value and go back and put it in to my first expression or to this new one here. I can do either one. But I'm going to put it back into my original expression just to make my life, or into my new expression just to make my life easy, because then x is already by itself. So I have x is now equal to 6 minus 2 times my new y value of 2.5, which gives me x equals 6 minus, well, 2 times 2.5 is 5, x equals 1. I'm going to write out my final answer. My x value goes first. Even though I solved for y first, my ordered pair always has my x value first and my y value second. So my final answer is 1 and 2.5. Well, now let's try this. So this one's out of the homework. I'm not sure which number it is. You'll have to check the assignment. I think it's 27 or 30. In the system, a plus b equals 7 and 29.2, my brain's not awake yet this morning, 1.29a plus 0.49b equals 6.63. A represents pounds of apples and B represents pounds of bananas. Guillermo and Kara are finding and interpreting the solution. Is either student correct? Explain. Well, let's look at this here. So I see for Guillermo that he has the first equation copied correctly. 1.29a plus 0.49b equals 6.63. Well, then it looks like he wanted to substitute in a plus 7 as the b value. Well, let's look. If I look at the original equation here, I have a plus b equals 7. So that means if I want to get b by itself, I have to take away a from both sides. Guillermo is not correct. He substituted in the wrong expression. So final answer is no, Guillermo is not correct here. He used the wrong expression for b. Well, now let's check out what Kara is doing. Again, she has the first equation copied correctly. 1.29a plus 0.49b equals 6.63. And then Kara decided to substitute in a. Well, let's see. If we want to isolate a from that original equation, we have to take away b from both sides, and I get a equals 7 minus b. All right, she's on the right track so far. Next step, she multiplied to distributed to get rid of those parentheses, and we get 1.29 times 7 is 9.03. Let's check and make sure. We have 1.29 times 7, and we get 9.03. That's correct. Minus 1.29b plus 0.49b equals 6.63. I like it. Now it looks like she combined two steps here. She put her like terms together, so we had a negative 1.29 and a 0.49. And we should get negative 0.8b. I agree. When we take away 9.3 from, or 9.03 from both sides, so 6.63 minus 9.03, we get negative 2.4. That's correct. Now we have b equals 3. If I divide both sides by negative 0.8, I agree, we get b equals 3. The solution b equals 3 means that 3 pounds of apples and 3 pounds of bananas were bought. Does she have enough work to support that yet? Well, no, she doesn't. So let's go back and check. I agree that b equals 3, so she has 3 pounds of bananas, but let's see if that's the correct number of apples. If I go back and I have that original expression of a plus b equals 7, a plus, well, now b is 3, equals 7, a should equal 4. So the final answer here for Kara is no. She is not correct. Neither Guillermo nor Kara were correct here. She has the wrong number of apples, or wrong number of pounds, because she didn't go back and substitute into that first equation. Everything she did, all the work she showed was correct, but her final answer was incorrect. So sometimes that will happen where you'll have both students are incorrect or both students are correct. Make sure that you're reading carefully. Many of you may have solved for Guillermo, figured out that he was wrong, and just automatically said Kara was right. Be careful when you're solving these kinds of problems. Your homework tonight is out of the textbook. Please make sure you have notes in your notebook and then turn to the next page to work on this homework task. You're doing page 347, numbers 3 through 30, the multiples of 3, and then 32 through 35. These are the multiple choice, or some of them are multiple choice, the kind of questions that you'll see coming up on standardized tests. Good luck. Send me messages if you have questions.